Hello, this is AP Physics C, FRQ Set 7, Question 6, the final one of the practice set. A 4 kilogram block slides along a frictionless surface with a constant speed of 5 meters per second. 2 seconds later, it begins sliding. A horizontal time-dependent force is applied to the mass, and the force is removed 8 seconds later. The graph shows how the force on the block varies with time. Alright, part A, what is the magnitude of total impulse of the force acting on the block? So impulse equals the integral of F with respect to time. Integral of force with respect to time. And the integral of force, in other words, is the area under the force curve. So in order to find the total impulse, we can just simply take the area up from the line of force to the x-axis. So here's a height of 6, and this rectangle goes from 2 to 8, so it has a length of 6, which means this is an area of 36. And then this part is a height of 3 and length of 2, so that's 6. So the total area of this is 42, and that will be our impulse. 42 newtons times seconds. Part B. Determine the block speed at t equals 1.5 seconds. So there's a constant speed of 5 meters per second until 2 seconds later. So from 0 to 2, there's no force, which means there's no change in speed, and time of 1.5 is within that no force zone. So the speed will still be 5 meters per second. Part C, determine the block speed at 6. Alright, let me erase this area stuff. So to find the block speed at t equals 6 seconds, we can find impulse again, and then change that, set that equal to the change in momentum. So we will take the impulse from 2 seconds to 6 seconds. And the impulse, once again, is the area, height of 6, length of 6 minus 2 is 4, and that will be 24. So J will equal 24 newtons per second, and impulse is also equal to the change in momentum. So 24 equals change in momentum is m times change in v. M is 4 kilograms, and change in velocity is vf minus vi. So we'll divide mass on both sides to get 6 equals vf minus the initial velocity. The velocity at time equals 2 is 5. So you get vf equals 11 meters per second. Okay, part D. Calculate the net work done on the block between 2 and 8 seconds. Okay. So net work done, we can find that through work equals change in kinetic energy. Work equals KEF minus KEI. So kinetic energy equals 1/2 mvf squared minus 1/2 mvi squared. So 1/2 times m is 4, so 1/2 times 4 is 2, times 2, and vi, the velocity at 2 seconds, is 5, so 5 is mean. But what is the velocity at 8 seconds? To do that, we would find impulse again. The impulse from, okay, let's erase here, from 2 to 8 seconds. As we found out in part A, this rectangle has an area of 6 times 6, or 36. So that would be our impulse. And our 36 impulse equals change in P equals M times Vf minus Vi. And our M is 4. So divide 4 on both sides, we get 9 equals Vf minus velocity at 2 is 5. So Vf equals 14 meters per second. And we'll just plug that into Vf here. So 2 times 14 squared equals, this is 5 squared is 25 times 2 equals 50. So minus 50. Work equals 14 squared is 196 times 2 equals 392. minus 50 equals 342 joules. That's part D. Part E. Calculate the distance traveled between 8 and 10 seconds. So we will find the impulse from 8 to 10 seconds, which is height of 3, length of 2, that is 6. And we'll find the VF of 10 seconds. So 6 equals 4 VF minus VI. We'll use impulse equals change of momentum again. This is 1.5. 6 divided by 4 is 1.5 equals VF minus the velocity at 8 seconds. We found that in part D is 14. And 14 plus 1.5 gives us a VF of 15.5 meters per second. We're supposed to calculate the distance traveled. So we'll use V average equals V average, or delta x over delta t equals VF plus VI over 2. We can use this because the acceleration is constant from 8 to 10, because force is constant from 8 to 10. So we're trying to find delta x, so we'll isolate for that. VF is 15.5. VI is 14 over 2, and our time is from 8 to 10 seconds, so 2. We can cross out the 2's, and we get delta x equals 29.5 meters. Okay. Lastly, for F, graph the position, velocity, and acceleration for the interval time equals 8 to time equals 10. Alright, let's have 3 quick graphs here. This will be x and t. This will be v and t. And this will be a and t. Alright, so like I said before, the force is constant, so A will be constant. Since force is 3 and mass is 4, that means F equals ma, and A equals force is 3 and the mass is 4, or 0.75. So A is constantly 0.75 from 8 to 10 seconds. For velocity, it starts at a velocity of 14, and since there's a constant acceleration, over 2 seconds, each second it will gain 0.75 meters per second. So 8, 9, 10, 15. It will stop at 15.5 at 10 seconds, and is a straight constant increase. Now for x. The position, it will increase exponentially because there's velocity and acceleration, so it'll start out moving up at a slope of 14 and it'll increase over time, something like that. And that is it. Hope you enjoyed that, and I'll see you next time.